Have you ever wondered what it would be like to survive practically anything? To possess an innate ability to simply decide not to die, no matter the odds? Well, prepare to be amazed, because we're diving into the real-life world of microscopic superheroes. Get ready to meet the tardigrade, often affectionately called water bears or moss piglets. Don't let their squishy, almost adorable appearance fool you. These tiny creatures, typically less than a millimeter in length, are the undisputed champions of survival on Earth. Imagine an organism that can be frozen solid at temperatures hovering near absolute zero. That's a mind-boggling minus 270 degrees Celsius. And then, astonishingly, it can be brought back to life after enduring boiling temperatures of up to 151 degrees Celsius. Think about that for a moment, from the chilling emptiness of deep space to temperatures hotter than boiling water. It sounds impossible, but for the tardigrade, it's just another Tuesday. Their resilience doesn't stop there. These incredible beings can withstand immense pressures, equivalent to being 180 kilometers beneath the Earth's surface. And perhaps most remarkably, they can shrug off doses of radiation thousands of times higher than what would instantly prove lethal to humans. It really makes you wonder, what kind of biological magic allows for such extreme fortitude? The ultimate test of survival, outer space. In 2007, a groundbreaking experiment during the Photon 3 mission launched tardigrades into low Earth orbit. And the result? They came back alive. They endured the complete vacuum of space and direct exposure to cosmic radiation. It was, quite frankly, mind-blowing and solidified their status as true cosmic voyagers. So how do they accomplish all this? Do they possess some kind of miniature, invisible force field? Not exactly, but something equally incredible. Their primary secret weapon is a remarkable, reversible metabolic state known as cryptobiosis. When environmental conditions turn hostile, whether it's extreme heat, bone-chilling cold, or a complete lack of water, a tardigrade simply shuts down. Its metabolic rate plummets to less than 0.01% of its normal active state. It's like hitting the ultimate pause button on life itself. During severe dehydration, a common trigger for cryptobiosis, the tardigrade undergoes a striking transformation. It contracts its body into a compact, barrel-shaped form known as a ton. This isn't just a random act. It's a critical morphological adaptation. In this ton state, the animal pulls in its legs and retracts its head, transforming into a desiccated sphere. This physical transformation is vital for maintaining structural integrity, minimizing surface area to reduce water loss, and protecting crucial internal organs during extreme stress. They can expel over 95% of their body water, effectively putting themselves into a state of suspended animation, waiting for more hospitable conditions to return. And how long can they wait? Try 30 years. Scientists in Antarctica successfully reawakened tardigrades that had been in cryptobiosis for 3 decades. What's even wilder is that this period of dormancy doesn't seem to count against their normal active lifespan. It's as if they were literally out of time, defying conventional understandings of biological aging and longevity. This phenomenon opens up fascinating avenues for research into reversible biological stasis, with potential applications ranging from long-term human space travel to organ preservation and even novel anti-aging therapies. But the tardigrade's astonishing resilience isn't solely about shutting down. It's also underpinned by a suite of incredibly unique internal safeguards. Think of them as molecular bodyguards. One of the most pivotal of these is a unique nuclear protein called damage suppressor protein, or DSUP. DSUP acts as a literal shield for their DNA when tardigrades are subjected to radiation, which typically wreaks havoc on genetic material by inducing DNA double-strand breaks. DSUP directly binds to their chromatin, forming a protective barrier around the DNA. It effectively mitigates radiation-induced damage by reducing the incidence of these breaks and preserving genomic integrity. The compelling evidence of DSUP's efficacy comes from experiments where scientists have introduced the DSUP gene into human cells. The results were astounding. Those human cells exhibited significantly increased resistance to DNA fragmentation caused by X-ray irradiation or exposure to hydrogen peroxide, validating subfunctional importance across species. And what about when they dry out? For that, they possess another set of specialized molecules, tardigrade-specific intrinsically disordered proteins, or TDPS. These proteins are like clever molecular sponges. When the tardigrade dehydrates, TDPS, unlike typical globular proteins, lack a fixed tertiary structure. Instead, they form non-crystalline amorphous solids, or glasses, within their cells. This vitrified, glass-like state is directly correlated with their protective capabilities, likely by physically trapping and stabilizing desiccation-sensitive macromolecules like other proteins and cell membranes. This mechanism effectively prevents their denaturation, aggregation, fusion, and fragmentation, keeping everything intact and ready for revival once water returns. For a long time, the popular narrative surrounding tardigrades painted them virtually indestructible. However, recent research has unveiled a surprising twist, revealing what some call a fatal weakness. It turns out that while they are incredibly adept at handling acute, short bursts of extreme heat, they possess a surprising vulnerability to prolonged, moderate heat. Active tardigrades, the ones wiggling around in their aquatic environments, can die relatively quickly if the water temperature remains around 37 to 40 degrees Celsius, just a little warmer than human body temperature for a couple of days. Even in their hardened ton state, their extraordinary heat tolerance significantly diminishes with prolonged exposure. For instance, while ton state tardigrades might tolerate 80 to 0.7 degrees Celsius for an hour, 63.1 degrees Celsius is enough to kill half of them within 24 hours. This fundamental discovery challenges the long-held notion of tardigrade indestructibility. It suggests that their survival mechanisms are primarily optimized for transient or acute extreme conditions, often involving rapid water loss and rehydration, rather than sustained, chronic thermal stress. This vulnerability has critical implications for predicting their long-term survival in a rapidly warming global climate, particularly for active populations where acclimation capacity may be insufficient. So why are these microscopic marvels, these true champions of extremotolerance, so incredibly important to us? Their significance extends far beyond their biological peculiarities. They are absolutely crucial for astrobiology. If multicellular life can survive such extraordinary extremes on Earth, what does that tell us about the tantalizing possibility of life existing on other planets or moons in environments we once considered far too harsh to support anything? And the molecular mechanisms they employ, they hold immense promise for biotechnology. Imagine the potential if we could harness their secrets. That sub-protein could inspire new therapies to protect cancer patients undergoing radiation treatment, or even safeguard astronauts during long-duration space missions. The principles behind their desiccation tolerance, mediated by TDPS, could revolutionize how we preserve biological materials, from vaccines and medicines that don't require refrigeration to the long-term storage of organs for transplant. We could even develop new forms of radiation-resistant materials inspired by their resilience. The possibilities for innovation are truly extraordinary. These tiny water bears are, in essence, teaching us how to survive even in the most unforgiving corners of the universe. Their story serves as a powerful reminder that even in the tiniest, most unassuming creatures on our planet, there are incredible secrets waiting to be discovered, continually pushing the boundaries of what we thought was biologically possible.